I'm Brian WA1ZMS, and I was asked to give this presentation today here at HamCon 26, as I call it, and talk about what I would call the new two top bands. We used to refer 160 meters as being top band, meaning it took, if you get on 160 meters with a decent antenna and do well in the contests or make good QSOs, you were a top band guy. Well, we have two new bands now. We've had them for quite a number of years, about 15 years now. And the wavelengths are 2,200 meters and 630 meters. And when Mitch wanted somebody to talk about this, he thought, well, who's been on those bands? And I was the only one he could think of, other than maybe Mike or someone else. And when JEZ is in the audience, who's going to help me out with some demos here, some show and tell on the talking about the band. So we'll get moving on here. I'm going to save the Q&A till the end. So if there's something you want to talk about, this has got some text in the front, and then there's a bunch of pictures for show and tell in the PowerPoint. And then we can chat about it, go back and discuss stuff, how you too can get on these bands. Some history and background. World Radio Conference, it used to be called WARC, Administrative Radio Conference. Now it's just WRC 12. In 2012 opened up both of these two new bands globally for amateur radio operators. However, prior to that, the ARRL knew this was going to happen, and so they had obtained an experimental, which is, of course, we're governed under Part 97 of the Commission's rules, and there's a radio service called Part 5, which is experimental radio services. Without getting into all the details with that, the league started applied for an experimental license and was granted one, and it actually included the original 500 kilohertz frequency, which used to be the maritime distress calling channel that the Coast Guard would monitor and ships at sea and all that stuff for decades. 500 kilohertz had fallen out of favor in terms of normal SATCOM, modern SATCOM and cell systems and all that. So one of the quote locals up here, Fred Robb, W1FR, he was my first employer out of college. I graduated from the University of Vermont in '88 with a degree in electrical engineering. And so, but I was in Virginia at that time. Jobs had moved on and I'd matriculated through my career. And so Fritz, as he goes by, he emailed me and said, hey, you're in the microwave bands and the millimeter wave bands. How about coming down the other end of the spectrum? So I joined the ARRL's coordinated project. And basically, that was the early days. The UK had a band temporarily at 73 kilohertz. There were a few folks outside of the league, folks that may know Advanced Receiver Research, that's actually run by W1VD. And then a friend of his, John, W1TAG, in the Connecticut, Massachusetts area, they were big advocates for getting on the low frequency bands. And so they also led the charge, and they had their own Part 5 experimental license. So we had a lot to learn. Unfortunately, the US was almost dead last in the world to gain access to these two bands. And the concern was, well, why is it taking so long? Well, the Utilities Technology Council, they run a large portion of the electrical grid, not at the local level, but at from the generation to individual distributors. And they use these low frequencies on the power lines to do contact closure, breaker resets, load monitoring, load balancing. So they're a Part 15 unlicensed service, but there was a huge concern they had that those darn hams are going to upset the US grid. Well, the ARRL expected this, and that's why we had over 40 stations on the air in the US. And myself alone logged about 30,000 hours of just running a CW beacon at high power just to show, and there's a 175 kV line a mile or so away from my house that has PLC on it just to show that we can coexist. So in the end, what they said was, all right, here's the deal. FCC modified the rules when they opened the band, modified, meaning they contoured these two bands specifically. So according to 97.303 G2, I won't get into it, but you must notify Here's the key word now. Notify the UTC of your intent to transmit. You can receive anywhere you want, but there is a website they have that I'll talk about later, but basically you go into the website, you add to the link, you put your information in there, you have 30 days to wait, and after 30 days, if they don't object, you're free to transmit. So that's all it takes. I'm going to switch something right here because in this freneticism of IT, I may have actually grabbed the wrong version of this right here, but let me just keep going. All right, so we'll get into the bands. The first band is 2,200 meters. This is by far what I would call top band. We're down here in 135 to 137 and change kilohertz. I describe it as it's a very narrow band, only a few kilohertz wide at best. All modes are permitted, but to be honest with you, majority of people in the world are running what the Europeans call MGM, machine generated modes. We would call them digi-modes over here, or digital modes. So I'm using the term MGM, not the movie company, but the acronym for that. On 630, we've got 7 kilohertz of bandwidth there. We can run all modes. There is a gentleman's agreement to the band plan. There's a CW segment, single sideband segment, and an MGM segment. And before you think and say, my God, I could never get on these bands, look at the fun fact. On 630 meters, a 100-watt amplifier into a decent T antenna, which I'll describe a little bit later, you get, with a good ground system, you get very close to the legal limit of 5 watts radiated power. It's not that hard. It really isn't. And what makes a good ground or counterpoise? Well, I would describe it this way. Put as many short radials as you can out at the feed point. And when you think you're done, go back to Home Depot or Lowe's, your DIY store or your scrap store, and go get twice as many ground rods and double the wire and put that in again. So if you can only put out 2 ground rods and 40 feet of wire, wait, get 2 more ground rods, 2 more 40 pieces of foot of wire, put those out. Just keep adding to it, adding to it. I must have, by today's prices, over $1,000 of copper buried in my yard in all different places. And we have underground utilities in my neighborhood in Virginia. So when the fiber company came to bury the fiber, I had to be there and paint my own line and say, don't you dare trench over here. You've got to hand dig and go all the way around here, because I'm not going to take thousands of dollars of copper and just have you guys cut right through it with a ditch witch. But you can do it. And again, at the end of credits, Rudy N6LF has written a lot of papers, a book, in fact, that you can get online. It talks about ground radials and all kinds of stuff. There are so many giants ahead of me on these 2 bands that have done a lot of research and done a lot of really good stuff. How to get started for me? Well, when I was part of the ARRL Part 5 experiment, I was also into collecting vintage antique wireless transmitters and receivers. It was supposed to be our daughter's college fund, or part of it. Well, about the time she hit 10, 11, 12, 13 years old, the antique wireless collectors market kind of crashed. And so I was part of the buy high, sell low. Bad idea. Actually, I didn't hold. I didn't sell, I'm holding. But one of the things I did is I built this replica 1921 transmitter that's in one of the handbooks at the time. It's called a MOPA. This is the back end of it. It's called Master Oscillator Power Amplifier. So it's a couple of vintage tubes. And believe me, this thing got its work out. It only runs 5 watts. But I started off with this. Had a very distinctive chirp to it on 500 kilohertz. And it was heard all up and down the East Coast, believe it or not, just with 5 watts transit power. So it's all possible. All right, so here we get into the rules. Always check the web for the latest link, but this is the UTC's current, as of this past week, their current website. You don't have to write it down, but just know that you have to look up UTC, not atomic time like we talk about, time nuts and all that, but UTC, Utilities Telecommunications Council. And do a web search, find their URL. All you need to do is enter your location data and hit submit. Then you wait 30 days. If you get no objections, emails back saying you can't do it, you're free to go. So far to date, only one amateur in the nation has been said no, and that was on 2,200 meters. So I think we're doing fairly well. In fact, they were inundated with requests because folks like myself who are from Vermont, have family up here. What locations would I list? My home in Virginia, my mountaintop repeater site in Virginia, sites in Vermont, because you can't operate mobile on these bands. It has to be a fixed location because of the UTC's concern. So if there's 10 places that I might want to operate from someday, why not just put in 10 submissions for both bands? And they could not believe the thousands of requests they got. But it just shows that as hobbyists, we're interested, and it showed the UTC that we really mean it. And you're all set and ready to go. So again, just to review, in the FCC rules, 2,200 meters is 1 watt effective isotropic or effective radiated isotropic power. I'm not going to get into the math, but that's the way of in electromagnetic space measuring power more than just ERP. You're limited to a 1.5 kilowatt maximum PA power, no different than HF 2 meters or anything else. Although on 630 meters, we have 5 watts of EIRP, we are limited to a 500 watt only power amplifier. It's because it's too easy with more power to exceed the 5 watt EIRP. So the commission or the FCC had to put some words in there to limit that. And in all cases, for either one of these bands, the antenna cannot be more than 50 meters above ground. So, and besides that works out to be 196.8 feet. If anybody knows anything about towers, once you exceed 199 feet, you got to light it anyway or go through the FAA. So unless you're a big contest station, you're probably not going to have this in your backyard. All right, so how did I get started? Always start by receiving. Start there. There's stuff on the bands. There's digital modes galore that are there. I built this thing, my gosh, probably over 20 years ago, and I still use it. This is just some pine wood I got at the local, Home Depot or Lowe's or whatever. And I built an old-fashioned antique radio loop, and I just put some enamel wire on there. It looks kind of vintage. And then I built a little preamp circuit down here. And I can take that loop, and it's pretty much broadband, and I can plug it into the preamp, which is just an op amp. Basically, it's just converting the impedance, this resin loop and cap, down to 50 ohms. And I've had this all over the East Coast. When I go on family trips, I pack it in a suitcase. Wife gives me an ugly look, and she just knows that I'm going to be up at 3 o'clock in the morning at some, hotel or something on the Outer Banks of North Carolina, listening to see who I can hear on the bands. But there's also all kinds of other antennas. We'll talk about it. One is we'll mention later on in the photos. There's small loops like this. There's E-field probes. There's something called a bog, which is a beverage on the ground. If you have 1,000 feet of old RG6 cable TV coax or something like that and have enough yard space or a farm, lay it out as a beverage on the ground. You'll be surprised how well it actually works. And it is directional too. You can switch directions which way it's receiving. And since here on the East Coast, the United States, most of us are looking for folks in Europe. So if you can run the thing sort of in an east-west pattern or direction, the bog is a great antenna. AA1A out in New Hampshire, he's got like a 500-foot loop in the air around his couple of acres of land, just shot lines over the trees and pulled it up. There's something called the quiet E-field type antenna probe. I haven't tried it yet. It's a vertical radiator, and people use Cat5 cable, twisted pair, balanced transmission line back, and they say you can make an E-field antenna that doesn't pick up a lot of QRM that way. You're going to have to get used to using number 77 ferrite. That'll be your friend for transmission lines and transformers and chokes and keeping stuff clean. Power lines are a problem, and especially Anything that uses electricity is your worst enemy. But before we get to an example of that, K9AY did a beautiful loop on the left here. There's the AMRAD eProbe kit that came out years ago, the Amateur Radio Advanced Development Group out of DC in Maryland. There's a picture of a diagram on the lower right of a beverage on the ground that W1VD did. So I'm not going to explain all this, let you know there are a zillion options out there. But there's QRM. And I have to thank Mike for this one because this is a beautiful example of what a waterfall display on 630 meters might look like. And Mike, I don't know if you want to say anything, there's no microphone back there, but I think you said the stuff on the sides, the flanks were the washing machine going between rinse and wash cycles, spinning up and going around. Why? Because all washing machines don't use an old-fashioned half horsepower AC inductive motor. They're all stepper motors, right? And they can slowly come up to speed and slowly ramp down, and it'll measure how much weight and how much water is in there, and it'll spin appropriately. So it requires a control system. As soon as you do that, what do you get? RF noise. Below is a photo of Mike sent of one of his E-field probes. He's got one up here. I'll have him come up if you want, or we can pass it around. I don't know what you want to do, Mike, when we talk about it. Pass it around? Sure. Okay, fine. We did. I can't pass it around for you folks on Zoom. I'm sorry. Actually got a picture. Oh, there's a picture in there. This is a different one. This is the one he had there was actually silver plated. There's a guy, the original one I think was out of the Netherlands. Was it a PE1 RKI or something like that? Had the original E-field probe. What does it do? Okay, it's an interesting antenna. Basically, there's a broadband preamp in there, and that little square patch near the top of the circuit board is just a little square patch. It uses a piece of coax that you put DC power to feed it up part of the preamp. The little patch and the shield of the coax is the counterpoise. Now, here's the thing. A small patch of PC board or metal plate, a couple square inches, is really not very effective at low frequencies, except if you treat it as almost a plate of a capacitor. Very, very high impedance. So you use a very high impedance FET to connect to it. And even then, you put a small series coupling cap in there. And it is amazing. I've got one at home. It's amazing what you can hear on those things all the way through HF as well. They're an absolutely amazing antenna. The trick is you do want to get it up in the air. So a lot of people will put it on a piece of pipe or whatever and just use the coax coming down in a piece of cable TV coax or anything like that. And that's the shield of the coax acts as the other part of the counterpoise of the antenna. So when it comes in the building, you might want to put some ferrite there or put it around it in a coil or something like that. So you bring it in the shack. You don't pick up all the washing machine and the microwave and the controller on the dishwasher and, everybody's Xbox and all that kind of stuff. So did I explain that, Bo, I hope, for you? Yeah. We could, each one of these things I could spend a half an hour just talking about on that. Yes. Yes. The question after Zoom, he said somebody gave him a loop antenna like mine. Yeah, that's from the 20s. That was the way most folks had home AM radio receiving antennas. The advantage of a loop is that it has a figure 8 pattern. So you have 2 peaks and 2 nulls. And the advantage of that is if you have something in your neighborhood or in your home or nearby that's causing you noise and interference, rotate the loop and null the noise. Don't peak the signal, null the noise. And unless you're extremely unlucky, the probability that the noise and the signal are coming from the same direction is very, very, very small. And if it's bad luck, move the loop antenna 15, 20 feet away, and then you can separate the two and all of us the angles of arrival, and you can know the noise. No, I run mine at home was taken in the basement, sitting on the basement floor below ground, and it worked just fine. Now, it worked better outside, but but it's amazing. In fact, they have people that have used buried loops in the ground in Europe to get on in places where there's their version of an HOA, where they don't want antennas in your yard or anything visible. In the UK, I guess they'd call it the garden.
Preamp that you built that website on transmitters.
Yeah, someone makes it. Mine is on W4DEX has got a copy of it, or email me, WA1ZMS at AWRL.net, and I'll send you a schematic. It's just an OP27, simple low noise FET op amp. It's about as dirt simple as you can get. And it's cheap too. So, well, what can you do? Well, this is what Mike did from up here in Vermont. These were DX spots that he had. Mike, do you want to comment on anything? I'll pass it. Yeah, Mike let this run overnight. Yeah, so just like I've done, Mike ran his Whisper transmitter at night and then went to Whisper Reporter. And as you notice, he was heard over in Europe, transatlantic path, and heard all over to the US. In fact, this map is kind of odd because if you're not familiar with it, there's the day, what they call the sun terminator. So Mike grabbed this screenshot shortly after sunrise here, local time. So that's why Burlington, Vermont, where all the dots are, that's in sunlight, and it was still, of course, dark. That sun hadn't risen on the West Coast yet. And I've done the same thing, and it's incredible. But I wanted to give, Mike said some stuff, which I think was great. Anyway, but to do stuff like this, you need people to receive. There's nothing more frustrating than spending 24 hours or 48 hours or a week transmitting and not have anybody spot your signal. Now, is that making a QSO? No, but it shows what your station's capable of if you were to switch to a different mode and make a two-way QSO, right? That's what we want to know. So you can start off as a receive only. There's several, the RSGB, Radio Society Great Britain -LF is their low frequency group IO page. Every day, Roger posts this on the right, and it's in my inbox. He posts every day the top 3 DX spots worldwide on 2200 and 630 meters. So using the top one as an example, on the VK6 MJM was heard by SWL, so some of these are just shortwave listeners, not even hams. EM3, I don't know who he is. We can figure him out. It was minus 43 dB, so that's 43 dB below a single sideband bandwidth. They used FW15 as a digi mode or MGM mode, and it was 16,823 kilometers. And then you keep going on. The next one, MJM, was also heard by KK6TJ, or TG rather. So again, this is great because you can put this on, come back 2-3 days later, and did you win? And your prize is bragging rights. But it's awesome to go ahead and get on these bands and see what's possible. And as we always say, you can't work them if you can't hear them. So not only is you spotting someone, you're also helping someone figure out whether their transmit system is working. Did they bury enough copper wire in the ground? It's a collaborative thing. It really is. And for that, you can spend, I don't know, I think it's like $150 and you can get a self-contained digital or SDR Whisper receiver. An antenna port, SD card has a firmware on it, Ethernet jack on the back, plug it in, leave it on, let it go. It'll even do band hopping. It'll sit there and scan all the bands and report as each spot is heard, digital modes posted on the internet on the reflectors. So it's a great way to also get started in some of the digital modes on HF as well. Just be a receiving station. Try your loop. All right, now you want to transmit. Well, Tech out of Sweden sells this really cute little Whisper transmitter, little PC board kit in the upper left. And I've got a couple of these. This is one that I built. The nice thing about his kits are he just uses some TTL gates and transistors to make like a 1/4 watt of power. And you have to build your own low pass filter. So, but he gives you instructions on what cores and what capacitors to use. So that's that blob down in the bottom of the circuit board here with the blue and the 3 capacitors and all that. That's just me grabbing parts off the shelf, building a low pass. I won't even get into how to calculate ERP. That could take 15 minutes, but there's plenty of places on the web. But you obviously will need this textbook, which is extremely important. And this is a little bit of humor for those that may not get it. It's known as probably hard to read if you're not in the audience, but it's called the Table of Universal Fudge Factors. Okay, that's a book that every engineer has on their desk. And so on the other hand, I decided to do a Whisper exciter, but then I wanted a little more power. So I followed W1VD's advice, and I bought online a Hafler 9505 audio amp. This was from I think the late 80s. Hafler Audio made this 500 watt audio amp. Out of the box, has a bandwidth of up to 300 kilohertz. It was designed for like rock bands and pro audio folks and all that. So it's a boat anchor. And it's not switched mode by any means at all. It's large and linear and heavy. But the great thing is it's an awesome amp. And so with this amp, there's a small mod. You change 2 capacitors, and now you have almost up to 700 kilohertz of frequency response. So it covers the 630 meter band just fine. Then it will also do about 500 or 600 watts. You can't put it into 50 ohms. You do need to transform it. So the transformer is about a 4-to-1. So you load it with 12.5 ohms with a transformer matched up to 50 ohms. And it's an awesome linear amplifier. Not like the high efficient amp. I'll pass this around now, Mike, if you don't mind. If you're not into boat anchors and you want to do something really efficient and you're not going to run something like single sideband on the 630, this is for 2200, I think you said, Mike. It's 60 watts? 60 watts. It's just a couple of power FETs and some transformer winding. You get used to it. But there's tons of designs out there like this that people have done. Pass it around too. So, that amplifier right there feeding whatever wire you can put in the air as a transmit antenna, and maybe a loop on receive if you're in a noisy environment or neighborhood, you're going to do just fine. Okay, what do? Here's just pictures instead of text. The antenna that I have in Virginia is a full wave 160 dipole. I lucked out. I got 2 oak trees on the edges of the property with nothing in between them. So I strung this up and I ran 600 ohm open wire ladder line as my feed line for HF. It's a multi-band HF antenna. If you get the line length right, for the majority of HF bands, it's a decent impedance and most transmatchers will tune it. But if you feed it against ground as a T antenna, it works great on both 2200 and 630 meters. So in the upper right, this is the side of the house where the parallel line comes down. And that's my little set of boxes out there with some transmission line transformers, some balance, a variometer, which is a variable inductor, and an ammeter. And I pulled the cover off it to take this photo, but I glued a piece of plexiglass in the front panel. So when I'm running in beacon mode or whatever, I can always go outside, walk outside, and just look at the antenna current, make sure that it's still what I think it is. And these are just thermocouple ammeters you can buy on eBay or any antique radio dealer guy. They're just thermocouples. And you can calibrate them with DC because all it is a very, very low value resistor, and they measure the temperature of it with, bimetallic strip and just feed a small meter. And so if you set it for, if it says 2 amps at DC, you can be guaranteed if it'll read 2 amps at low frequency just fine. RCA had a lot of these in their old HF military gear. On the lower left, and it's at a right angle so I could fit it, that's a 5-gallon bucket from your local DIY store. That's my 2200 meter loading coil, and I call it a variometer because down inside of it, there's another 4-inch piece of PVC plastic with another inductor in there. And all you do is roll one inductor versus the other, right? So instead of changing taps on the inductor, you want to vary it. If you have 2 inductors in series and one is inside the other, and you rotate the one in the middle, right? What happens? Some of the magnetic field cancels, and in the other direction, some of it adds. And now you have a very nice tunable inductor. Now you may have to find out how many turns you need. You may have to tap it and such to get it right. But I will warn you about one thing, and that's why there's this vacuum relay down here in the bottom. Because I have a relay out in this box outside, and what it does is I take the parallel transmission line and I switch it between the HF balun, right, to feed, or the other relay position shorts the 2 wires together from the transmission line. That feeds a variometer that then I feed against ground. Well, think what you're doing. At 2200 meters, if you start running some power, you basically are starting to imitate who? Tesla. You're basically making a Tesla coil. My biggest mistake was for that relay I needed outside, I bought a ginormous contactor at Dayton one year. I said, this is great. This thing is huge. This thing is going to work awesome. And it did until I went out and checked it in the spring after doing some stuff on 2200 meters. Whatever plastic insulating material they used in that thing does not like RF. It handles AC just fine, DC just fine, but don't start putting 130 kilohertz into it because it was just melting and destroyed. So I found online for $50 a 30 kilovolt vacuum relay, double pull, double throw. It's a once in a lifetime find. So that's my switch now that I use to switch between. So I can sit in the shack and just flip a toggle switch and the antenna switches modes outside because I'm lazy. I don't like going outside and, moving jacks around and clip leads. I got tired of that. And then you learn to build transmission line transformers like the one here in the box down below in the picture. And by the way, any box you put outside, put a drain hole in it, please. And don't make it so big that mud wasps or bees and hornets are going to get in there. In fact, you're better off with several in the corners, tiny, tiny drain holes, weep holes, rather than one big giant hole. So my first 630 QSO was simple. I used CW. My second QSO was with Eric, NO3M, on sideband, 630 kilohertz. That's where the linear half-floor amp came in real well. Had a problem with the sideband distorting because you tune your antenna for a portion of the band, you're limited bandwidth. So there was some audio distortion in there, but we had a great QSO. MOSFET amps like we just passed around here are cheap. For my first QSO on 2200, I had it with N1BUG up in Maine. We ran QRSS, slow speed CW. We set up a SCAD ahead of time. He'd transmit one night, then I'd transmit the next night. We'd go back and forth, back and forth, back and forth. But I was tuning up, as you say, and the family found out that Dad's up to something because all the smoke detectors in the house went off. Because the RF field strength was just enough to trip. And of course, they're all interconnected, right? So if one goes off, they all go off. So all I know is I'm hitting right around 750 watts. And I hear this bleep, 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 bleep. And the cats go nuts. My wife and daughter go, what the hell's going on? Oh my God. So I got to wait for the smoke detectors to mute. Put everybody back, calm everybody back down, grab another beer, go back down to the shack. And then just run at 600 watts. Again, lots of opportunity to build. If you're a home brewer and you like building stuff, this is the thing for you, all right? QRP Labs, sells low pass filters for their gear. That's the box is not theirs, but the circuit is theirs. This is one of these little. They're out of business now. The rights to the QRP world to build this watt meter has changed. It's been under many different names. I think this was the WM-2. It was a QRP watt meter. I changed the ferrite material, and it works great on the two low bands. So all I had to do, change the ferrite material in the SWR bridge, 2 cores, problem solved, works great. Down here in the lower center is what's called a scope match. This is the way some people tune their antennas. It's basically you're doing a sample of the voltage and the current on the line. You feed it to a dual trace oscilloscope. You see 2 sine waves. Your job is to tune the variometer or change your taps until you see both sine waves line up right in phase, one on top of each other. Now you know that your voltage and currents are in phase, so that means you're feeding a resistive load. The antenna's tuned, everything's working fine. I also have an RF ammeter in the upper right, put in a box, thermocouple. I've got BNCs and banana jacks on it. I can take it anywhere I want, use it in the field, set up portable operating, whatever, do. In the center is a high power, low pass filter. Again, W1TAG and W1VD did some designs that I stole. So they say plagiary is what is it? Best form of to flatter someone, just plagiarize what they did. So that's what I did. And then did the same thing down here. This is a multi-tapped transformer. So I can step anywhere from, I can convert 50 ohms up to 200 all the way down to 3 ohms by just changing a couple of switches, rotating taps in a transformer. If you really want to see some pro work, very, very professional, very well done, go to W1VD site. Don't go to his advanced free research. Just go to w1vd.com, and he's got some beautiful examples. Jay does some fine construction work, top notch. And it's just, and so he built a switch mode amplifier over here on the left for, again, broadband. They'll do about 250 watts. And then he built a power combiner. And I built this same power combiner to combine 2 Hafler 9505s together if I want to, for linearity. Don't exceed the power limit, but just, back it down and just make sure you can run sideband with it. And if you're using your oscilloscope, I printed this. It's on the corner of my workbench. It's just watts, dBMs, volts RMS, volts peak to peak. So it's a quick lookup because I'm an engineer. I can't do math in my head. And this occurred to me when I was a student at the University of Vermont back in the 80s. I was in a modern physics class running things through a calculator, and I found myself typing in 2 times 3.1415. It's 2 pi. I realized I just can't do it in my head. I have to type everything in and do it. I'll just look it up this way. So call it my cheat sheet, my AI sheet. And I ran through that pretty quick because we started late. So yes, question. Propagation modes. Oh, there you go, microphone. Go ahead.
Sorry. Could you explain propagation modes associated with the 2 bands?
Sure. There are two primary propagation modes. There's ground wave and sky wave. It's very similar to HF. There's no anomalies. You don't have any meteor scatter. You don't have anything abnormal or I want to say out of the norm, like you would have even meteor scatter. People even run on 10 meters can do that. You don't have any of this at these low frequencies. So in fact, how you can tell how the signal arrives to you, that small loop antenna that I built, okay, when we started off on 500 kilohertz, the Navy had something over in Virginia Beach area somewhere that was on the band as a beacon. And when you're running under experimental license, you're not supposed to cause any interference. Well, they were not in the database. Nobody knows what the Navy does. That was their own business. We just didn't want to transmit on top of them or cause them problems. But nobody could DF where they were from. But I was the closest station in Virginia. So what I did is I used the 600, that small loop I built, it's only about this big, all right? I could tell the propagation and how it was arriving by a ground wave. If I took it out in the driveway, set it on the ground, could null the beacon to the east or peak it, right? As it turned into skywave, the signal would start to fade. If I tilted the loop back towards me, now the loop is centered at elevation. So now I could tell the difference between ground wave and skywave. In doing that from a couple of different places in Virginia, I was able to pretty much nail it that definitely it's coming from the Virginia Beach Naval Facility out there. And at that point, we just on email just agreed, don't operate on, I forgot what they were on, something like, 501 kilohertz. Just avoid that completely. Just don't bother them. We don't know who they are. The call sign was NEED, N-E-E-D in CW. No one ever knows what they needed, but they were there. Any other questions or comments? Yes. Yeah. There's the mic coming your way.
QRP Labs now sells a 630 meter filter for this radio.
You are right. I forgot to mention that. You're right.
So for Digimode, 5 watts, and you got it. This particular one is modified for my own station, and it has a direct connection to the receiver because there's a lot of noise in here, and I wanted to use it with a beverage antenna with a very low signal level. Okay. So I ran it out separately. Okay. And then I used to use a L-Craft for 630 meters, which only needs a or only puts out a milliwatt. So this doesn't even have the output stage installed. I just took the driver square wave in series with a resistor, and it just goes to a coax cable to a 50 ohm resistor on my amplifier. That gives me a square wave drive, and I'm off on whisper or whatever. Okay. That's good. The other thing, of course, last month, if you happen to have, like almost everybody does, an IC 7300 radio, they can be modified. You're on 630, transmit and receive directly. The only thing you need is to build a low pass filter.
Yeah, I build low pass filter. Yeah, so there are rig mods out there. Some of the Europeans also might modify the ICOM 735, which is that's an older radio now. Yeah. I mean, it came out in the 80s, but you can buy them for something like $150 sometimes. Right. And so if you want to, attack a radio, try that one as well. Yeah.
Yep. The other thing, I started to get on SOTA, and I needed an SWR meter, so I bought this little thing. Okay, which is QRP. It's 1 to 10 watts.
Okay, cool.
I accidentally, I wasn't thinking, I connected it to my to a 2200 meter project that I'm working on. It's not rated for that. It worked. This actually works on 2200 and 630 meters, 1 to 10 watts.
I believe it. Yep.
And it absorbs almost all of the power, though. They don't tell you that in the instruction manual. When I started getting on SOTA, I wasn't contacting anybody until I removed this from the circuit. This actually takes 5 watts and reduces it to 1 watt to run it because there's no battery.
I know what you're talking about. I've seen those. Yeah, there's some of the QRP watt meters. You have to be very careful with it. You're right. They actually have an internal dummy load, and the whole point is, I think the reason they do that is they want to resistively load whatever antenna you might be using to protect the transmitter, and then you do have to take it out of line once you get it tuned up and working.
But this is actually a really nice gadget. Yes. This is actually directly readable with sunlight falling directly on it, the little LEDs, and it'll read down to it's very accurate.
Yeah.
What is it called?
QRP SWR meter, maximum 10 watts from China, off eBay. Yeah. It's almost like magic. It works so well.
Yeah, I've got some.
It's got a microprocessor in it. I mean, it's a serious thing. It's not.
Yeah, QRP kits made one similar to that. It was on a full circuit board, and but that just was. That's probably just that type of design modified and packed in there.
Yeah.
So that's great. I mean, it's amazing what's out there for stuff that's available for these bands. Also, if you're looking for ferrite, for inductors and all that, switch mode power supplies, old desktop PC power supplies that are failed, you find them at, they don't even, people used to give away to Goodwill. Nobody wants them anymore, right? Everybody's using laptops. So just take it, rip it, steal it for parts. Take the coils out of it, take the caps out of it. There's your stockpile. There's your parts. I'll tell you what, that's cheaper than trying to order something from DigiKey or Mauser, right? And even if you have to pay the $9.95 ground shipping, you're still going to wait 4 or 5 days for it to arrive, plus the cost of the parts. So dumpster diving, that's the way to go.
What happened? All right.
Yeah, ferrite cores for winding transformers, impedance transformers. Now, a lot of the times you have to understand, and again, this could be a topic unto itself, and is, whether it's ferrite or whether it's iron core, it makes a difference. Iron cores are more for inductors. Ferrite material are for transformers. So you do want to know the dip. So there's a difference. Usually the color of the material, if it's painted blue or completely red or completely white, if it's completely covered in paint, then it's usually an iron core.
So was that loop antenna, would that really be good for the AM broadcast band too?
Yes, it is. Yep. And the preamp is broad enough. There's no tuning in that at all, except what I did do is if you run it in untuned mode, you just build a loop and put it into the preamp. Okay. Now, if you want to peak it so it actually is tuning, so you're actually getting a little more better impedance match, you place a capacitor, and I just use a pair of clip leads with a cap across the loop. And now I've made a parallel resonant circuit.
Do I need a preamp just to use that antenna by itself on AM broadcast?
Not for strong stations. You got to
Okay.
think about what you're doing. The loop antenna is just a coil of wire. So you got to think about how are you going to connect that to the receiver. If the receiver's got a 50 ohm input, okay, and you're going to put a coil across it, you're not going to have a very good impedance match. So therefore, you're only going to get but so much signal out of the loop and into your receiver.
And where's a good place to get that preamp or to see the schematic?
Again, you can email me, or W1DEX has a copy of the schematic on his webpage.
Okay, thanks.
Next.
All right. Thank you, Brian. Any other questions? Are we all set? Thank you.